0.6, 0.6, 0.6. We can choose either one. If this happens, you should choose the first one, which means in alphabetical order. This way you will have the same answer as the rest of the class. And will make it easier for us to grade also. So if you get into this kind of situation, just choose in alphabetical order. So I'm going to choose A here. So we will choose the attribute A and split the tree. A has two values, as A1 and A2. The objects which have value A1 will go to the left side of the tree. These are X2, X3, X4, and X6. So A was removed here because we used it to split the tree. So what we have left in this subtree is F, G, and C. So we're just going to copy the values for these objects for F, G, and C. So for X2, F is F2. For X3, F, F2. For X4, F is F1. And for X6, F is F2. G is, for X2, G is G1.
That X4 should be F1, right? X4 should be F1.
Which one?
That one under F, X4 should be F1, right?
X4, yeah, X4 is F1. Yes, thank you. X4 is F1. X3, G2. X4, G1. And X6, G3. And for C we have C1, C1, C2, C2. On the right side of the trees, objects that have A2, these objects are X1 and X5. So we're copying F, G, and C. Here we have F1, F2, G3, G2, C2, and C2. Now, you see something here. All these objects have the same value for C, the decision attribute. So that's a leaf. In other words, if A is equal to 2, then C is equal to 2. So this, we don't need this. We're just gonna over here say that C is equal to 2 and create a leaf. keep splitting this table until we get leaves, and when we get leaves, we're done. So we need to calculate entropy for F and G for this table. That's going to be table 2. So for table 2, so these were for table 1. Now for table 2. Entropy table 2 for F. We have F has 2 values, F1 and F2. For F1 we have all objects have the same value because it's only one object. So that should be 0. But there are 4 objects here. One of them is F1. So 1/4. Entropy is going to be 0 because all the objects have the same value for decision attribute. The rest of the object 3 out of 4, we're gonna do out of the 3, one has value C equal to 2. So one of the 3 has C equal to 2. So it's going to be minus 1/3 log 1/3. And two of them, which is x2 and x3 have C equal to 1. So if we calculate this, we will get 0 plus 0.4 that's equal to 0.207. For the attribute G, we get 3 values, G1, G2, and G3. For G2 and G3, the entropy will be 0 because there's only one object. One over 4 entropy 0 plus 1/4 entropy 0 plus the 2 which are left. We have a 50-50 split. The 2 that are left are x2 and x4. One has C1, one has C2. So half of them, it's a 50-50 split, so entropy is 1. If we calculate this, we will get 0 plus 0 plus 2/4 is 1/2, so that's 0.5. will choose the attribute with a smaller entropy. So which one are we going to choose? We're going to choose F, because it's 0.2 and G is 0.5. So next, this table will be split on F. So F here split. F has two values, F1 and F2. F1 there is only one object that has F1. That object is X4, which means that we have a leaf. If F is 1, then C is 2. So we're just gonna create a leaf here and say C2. And on the other side, if F is 2, we have some of the F2s have C1, another F2 has C2. So we're gonna create a table here. That's gonna be table 3. So in the table 3 we have X2, X3, and X6, and the attribute G and the attribute C. So we have G1, C1, G2, C1, and G3, C2. This is table 3 now. So normally if we have more attributes here, we will again calculate entropy for the new table T3 and choose the attribute with the smallest entropy and split based on that attribute. Now we only have one attribute, so we don't have to calculate entropy because we don't have a choice. We have to use this attribute to split the table, so we will use G and split it. And when we do that, what will happen is if we split on the attribute G, 3 values we have for G. We have G1, G2, and G3. For G1, we will have C1. For G2, we will have C1. And for G3, we will have C2. So this is how our tree looks like. So we have created the tree now. So that is a decision tree, which means the tree is gonna tell us what our decision attribute value is gonna be. So if we wanna have C1, then, or if we want to have C2, we can go, if A is equal to 2, then C is equal to 2. So we can write down this rule by traversing the tree, because the problem is asking us to find rules using this method. So the rules will be
had suppose we had two G1s with location RB0.
Speak louder because we can't hear you.
Last statement,
Yes?
we had two rows having G1 values with different values of C. So we would have to, basically had like
Uh-huh.
G1, G2, G1.
So if it was another G1 here,
Yeah.
but it has C equal to 2.
C, two different values of C.
Yeah, so if you have that, you have to create a possible rule and say confidence 50% C1, 50% C2 for that rule. I think we had that in previous problem. So by traversing the tree, we're gonna write the rules. The first rule is if A is 2, C is equal to 2. This is what our tree is telling us. The next rule is gonna be if A is equal to 1 and F is equal to 1, then C is equal to 2. Next rule is if A is equal to 1 and F is equal to 2 and G is equal to 1, then C 1. Next is A is equal to 1 and F is equal to 2 and G is equal to 2. Then C1. A1, F2, G2, C1. And the last one. If A is equal to 1, F is equal to 2, G is equal to 3, C2. And these are the rules. So these rules is the answer for this problem. Because the problem was asking to find the rules using this algorithm. This is the first problem.